Good afternoon, students. Today we are going to start a new chapter called as light. You might have seen a beam of sunlight when it enters through a room through a narrow opening or a hole. You may also have seen beams of light from the headlamps of scooters, cars, and engines and trains. Similarly, a beam of light can also be seen from a torch. Some of you may have seen a beam of such light from lighthouse or from an airport tower. What is those experiences suggest? Bojo recalls an activity performed in class. In that activity, he looked at a lighted candle first through the straight pipe and then through a bent pipe. Why was the Bojo not able to see the candle through a bent pipe? This activity shows that light travels along straight lines. How can we change the path of light? Do you know what happens when a light falls on a polished or a shiny surface reflector? One way to change the direction of light is let it fall on a shiny surface. For example, a shining stainless steel plate or a shining spoon can change the direction of light. The surface of the water can also act as like a mirror and change the path of light. Have you seen the reflection of trees and buildings in water? Any polished or shiny surface can act as a mirror. If you have learnt in classics that a mirror changes the direction of light, for this change of direction by the mirror is called reflection of light. Can you recall an activity in which you got light of a torch reflected from a mirror? Take a torch, cover it with chart paper which has 3 narrow slits as shown in the figure. On smooth wooden board, fix a plane mirror vertically on the chart paper. Now direct the beam of light on the mirror from the torch with slits. Place the torch in such a way that the light is seen along the chart paper. Now adjust the position so the light from the torch strikes the plane mirror at an angle. Does the mirror change the light that falls on it? Yes. Reflection of light in the water. Look into the mirror along direction of reflected light. You see slits in the mirror. This is the image of the slits. Here's how to show that light gets reflected from a plane mirror. Just play around with images formed in mirrors and know a little more about them. Place a lighted candle in front of a plane mirror. Try to see the flame of the candle in the mirror. It appears as if a similar candle is placed behind the mirror. The candle which appears behind the mirror is the image of the candle formed by the mirror. The candle itself is the object. Now move the candle to different position in front of the mirror. Observe the image in each case. See, this is the image of a candle in a plane mirror. Was the image upright in this each case? Did a flame appear on the top of the candle? Such an image is called an image formed by a plane mirror is erect and of the same size. Now place a vertical screen behind the mirror. Try to obtain the image of the candle on the screen. Can you get the image on the screen? Now place the screen in front of the mirror. Can you get the image on the screen? Yes. Find that the image of the candle cannot be obtained on the screen in either case. What about the distance? Take a chessboard. If a chessboard is not available, draw a chart on paper 64 squares. Draw a thick line in the middle of the paper. Fix a plane mirror vertically such that place any smaller such as a pencil sharpener to the boundary of the third square counting from the mirror. Note the position of the image. Now shift the object to the boundary of the fourth square. Again note the position of the image. Did you find any relation between distance of an image and that of object in front of it? Paheli made a note in her book. In a plane mirror, range formed behind the mirror. It is erect and of the same size from the mirror. When you see your image in a plane mirror, it is exactly like you. Have you ever noticed there is something interesting between you and your image? Left hand appears on the right side in the image. Bojo saw an ambulance on the road. She was surprised to see that word ambulance in front of it was written in a strange manner. Can you now understand why the word ambulance is written as in the figure 15.9? The driver of the vehicle ahead of ambulance looks in her rear view mirror. She can read ambulance written on it and give way to it. It is the duty of everyone to allow an ambulance to pass through without blocking its way. You might have observed that in the side mirror of the scooter or car, the images of objects appear are smaller than the object themselves. Playing with spherical mirrors. Pahle and Buju were waiting for their dinner. Buju lifted a stainless steel plate and saw her image on it. This plate acts as a plane mirror. My image is erect and is of same size. Paheli saw her image using the back of the steel spoon. Buju, look here. You can also see my erect image, though it is smaller in size. This spoon also acts mirror of some kind. You can also use a spoon in a curved shining surface to see your image. Now look at our image using inner side of the spoon. You find that the image is erect and larger in size. If you increase the distance of the spoon, you may see your image inverted. If you can also compare the image of pen or pencil instead of your face. The curved shining surface of the spoon acts as a mirror. The most common example of a curved mirror is spherical mirror. The reflected surface of a spherical mirror is concave. It is called concave mirror. If the reflecting surface is convex, it is called as convex mirror. Why are convex mirrors called spherical mirrors? Take a rubber ball and cut the portion of it with a knife or a hacksaw blade. The inner surface of the kid ball is concave and the outer surface is convex. The inner surface of the spoon acts like a concave mirror. The outer surface acts like a convex mirror. We know that image of an object formed by plane mirror cannot be obtained on screen. Take a concave mirror, hold it facing the sun. Try to get the light reflected by the mirror. Sheet of paper. Adjust the distance of the paper until you get a sharp bright spot on it. Hold the sharp bright spot on it. Hold the mirror and a sheet of paper steady for a few minutes. As the paper starts burning, this bright spot is in fact the image of the sun. Notice that this image is formed on a screen. Image formed on a screen is called relay image. The image formed by a plane cannot be obtained on a screen. Such an image is called virtual image. Image found by a concave mirror can be smaller or larger in size than object. The image may also be real or virtual. The concave mirrors are used for many purposes. You would have seen doctors using concave mirrors for examining eyes, ears, nose and throat. Concave mirrors are used by dentists to an enlarged image of teeth. The reflectors of torches, headlights and scooters are concave in shape. Bujo observed his image in the shiny surface of the bell on his new bicycle. He found that his image was erect and small in size. He wondered if the bell is also a kind of spherical mirror. Can I recognize? Note that spherical reflex of the bell is convex. Did you get an image larger in size than the object? Can you recognize the mirrors used as side mirrors in automobile? These are convex mirrors. Convex mirrors can form images of spread over large areas. So these help the dialers to see the traffic behind them. You might have seen a magnifying glass. It is used to read a very small print. Observe the body parts of a cockroach and earthworm. This magnifying glass is also a type of lens. Lenses are used in spectacles, telescopes and microscopes. Try to add a few more uses of lens to this list. Get some lenses, touch and feel them. Touch and feel them. These lenses feel thicker in the middle than at the edges. Then this is a convex lens. Those which feel thinner in the middle and thicker at the edges. Concave lens. Notice that lenses are transparent and light can pass through them. This is a concave and convex lens. Did you get sunlight white or colored? Have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is low in the sky. The rainbow, seen as a large arc in the sky with many colors. How many colors are present in the rainbow? When observed carefully, there are 7 colors in a rainbow. Maybe not easy to distinguish all of them. These are red, orange, yellow, blue, indigo and violet. You might have also seen when you blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of a compact disc, you see many colors. Could we say sunlight is a mixture of different colors? Probably I want to tell you that you can see a rainbow only when your back is towards the sun. Back is towards the sun. Thank you.